Good morning. Thanks for coming today. My name's Stuart Marks. I'll be talking about sequenced collections today, one of the new collection APIs we added to JDK 21. Before we start, safe harbor statement, I just wanted to let people know that no stochastic parrots were harmed in the creation of this presentation. Okay, brief overview of the collections framework as I see it. So a lot of people think, oh, collections framework, they're data structures, which is true. They're implementations of data structures, like hash tables, arrays, linked lists, trees, and stuff like that. So it's all good stuff. But the collections framework is also a system of abstractions, and they're abstractions over containers or aggregates of elements. And those abstractions have certain characteristics. So notice I'm shifting here. Instead of talking about data structures and links and pointers and things, I'm talking about abstract characteristics of these containers. For instance, you might want to have a container that contains only unique elements, or you might want to have a container that maintains the elements in a specific order, or that maintains associations between elements, or that maintains the elements in sorted order. So these are all abstract characteristics as opposed to how things are allocated and what objects point to each other. Now in the collections framework, these abstractions are embodied in a set of interfaces, which I think everybody should be familiar with, such as our usual list, set, map, and navigable set, and things like that. So I think people sometimes have a little bit of trouble navigating these kind of things, this duality between implementations and abstractions. And so one approach for people to deal with this is a flowchart. This is somebody else's flowchart I copied from the web. You can see the link there. One of the things about this, though, is that it linearizes the decisions. It's like, what kind of collection do you want? Well, the first question is this, then the second question is this. And I think that's a little bit misleading because it doesn't let you really consider the totality of what you need. And the way you can see this here is that there's this decision point, which is order important? That actually occurs twice in this flowchart. So maybe the flowchart isn't the right thing to do. So at one point I suggested an improvement to this, and so this is my choice for what not to use as the right collection. And it's really great. The internet is such a wonderful thing. I posted this and I got some feedback from somebody who said, that's not how flowcharts work. It's like, okay, thank you. All right, so if flowcharts don't work, then I'm just going to step back into my comfort zone, which is abstract concepts expressed in words. And so I wanted to talk about two characteristics of collections that we're going to focus on today. So the first characteristic is, does it allow duplicate elements, or does it require unique elements? Okay, and so now, what's a duplicate and what's a unique element? Okay, so there's a definition for this, which is based on object.equals. So if something allows duplicates, then you can have two elements or more elements in the collection that are .equals to each other. On the other hand, if you have a collection that says this contains unique elements, then we have this sort of mathematical proposition. There are no two elements in this collection that are .equals to each other. Okay, so that's an important property. Okay, so the second characteristic I want to talk about is, are the elements ordered or unordered? And so the term that the specifications, the term that we're using in the specifications for ordering is what's called encounter order. So does the collection have a defined encounter order, or does it not have a defined encounter order? Now, this is pretty subtle because, okay, so a hash set is the typical example of a collection that does not have a defined encounter order. And so if you iterate a hash set, then you get those elements in some order. And so people say, well, isn't that the order of the hash set? What do you mean by this encounter order? That's the encounter order of the hash set. But that's not really true, because the order that you get the elements out of a hash set is not defined. And so there are other sets like set.of, which are actually randomized. And so the order of those kind of collections is not defined. And the reason is that if you run the system again, you might get the elements in a different order. Or if you take a hash set, you get the elements out in a particular order. Then if you add an element, well, it might rearrange the ordering of those elements arbitrarily, because the ordering in a hash set is not defined. It does not have a defined encounter order. On the other hand, there are some collections like list where you put the elements in, and you expect them to stay where they are because they have an ordering. And so that's this semantic notion I'm trying to bring out here is, does this collection or this collection type, like list or set, have a sense of a defined encounter order? Okay, so let's take those two characteristics and put them into a little table here. So we have two columns, whether the collection permits duplicates or whether it requires unique elements, and two rows, whether the collection is unordered or ordered. And so if we look at the interfaces that embody those characteristics, an unordered collection that allows duplicates is a collection, Java util collection, the actual interface type collection. An unordered collection that requires unique elements is a set. That's the whole point of a set, is that you don't have duplicates in a set. Now, if you have an ordered collection that allows duplicates, there's a list. I think everybody's familiar with list. Oh, but there's this other interface there called dec, and it's completely independent of list. And then moving on to the fourth quadrant, we have what's an interface that embodies an ordered, where the elements are ordered, but they are required to be unique. And it's like, well, I put an asterisk there because there's a whole discussion about this. Okay, so actually, let's go back to an ordered collection that permits duplicates. So list and dec are both interfaces that have these characteristics, but there's no commonality between them. Their most common supertype is collection, which is different. So and also they have different operations on them, and so dec has a bunch of interesting stuff on it that list does not have. And so there's this weirdness about the collections framework. There's something missing here. There's nothing that embodies the commonality, the common characteristics of list and dec, and they also have different sets of operations that it's like, oh, if you want this operation, use a list. If you want this operation, you use a dec. And it's like, well, why should I switching? Why isn't there anything that expresses the commonality of those? So an interface is missing. All right, so now let's move over to the other corner here, an ordered collection that has unique elements. Is there an interface that does that? Well, kind of, sort of. There's sorted set and navigable set, but they actually have a different property, which is they require sorting. And so the elements have to be comparable to each other, and a sorted set and a navigable set maintain them in sorted order. So you can't just put an element there and have it stay there because sorted set and navigable set want to keep those in sorted order. So you don't have something that has this notion of an explicit ordering. Well, there's LinkedHashSet. And LinkedHashSet is a nice thing because if it's a set, but if you insert elements into it, then they stay in the order in which you've inserted them. So we say that a LinkedHashSet has its insertion ordered. Okay, and that's nice, and that has this property of being ordered, but also having unique elements. But it's an implementation. There's no interface that corresponds to LinkedHashSet that means this is an ordered collection that has unique elements. So again, an interface is missing here. All right, so what do we do when we have missing interfaces? Well, let's add them. Okay, so in JDK 21, I integrated JEP 431 sequenced collections. And that adds 3 interfaces to the collections hierarchy. It adds sequenced collection, which is just like a collection, but it adds the additional semantics that this collection has a defined encounter order. Okay, SequencedSet is a sequence collection that also imposes this additional characteristic of having unique elements. And then there's also SequencedMap, which is sort of the corresponding map equivalent of having the entries in sequence. So the main thing is that these interfaces are the ones that were missing from the previous slide, which is interfaces that express things like ordering and uniqueness. So we filled out the bottom row of that table. The nice thing is once you have a collection that does have a defined encounter order, then you can add some additional operations on them that make sense, but only on collections that have a defined encounter order. So for instance, we can add, get, and remove elements at either end, the front or the first or the last element in the collection, and we can also do iteration in reverse. And so I'll have more descriptions about that. And I'll just note that this is the first time that fundamental interfaces have been added to the collections framework since 2006, which is quite a long time ago. So this is a significant evolution. All right, so here's a diagram that explains what I just said. All right, so this is the collections hierarchy, or some of the collections hierarchy of mostly interfaces, with the exception of LinkedHashSet and LinkedHashMap, because those were the implementations that have no corresponding interface. So this is, I mean, this has been familiar. This has been, I think almost all of these have been in the system since JDK 1.6 or so. So we have collections, set, list and deck down at the bottom, and then on the, let's see, on your right, we have the map interfaces with the sorted navigable map and LinkedHashMap. Okay, so in JDK 21, oh, actually, one point about this is you can see there's no relationship between list and deck until you get up to collection. And some of the things on here are ordered, like sorted set and LinkedHashSet have a defined encounter order, but their supertype is set, which is unordered. So you can see there's something missing here. And so if we look at what the hierarchy looks like in JDK 21, you can see where sequenced collection goes in at the right place above list and deck, and it also goes in above sequenced set, which goes in at the right place to embody the commonality between sorted set and LinkedHashSet. And we have a similar thing going on over on the other side with the map. With the map hierarchy, we've inserted SequencedMap as a supertype of sorted map and LinkedHashMap. Okay, so let's dive into the what details are in the actual interfaces. The sequence collection interfaces adds this family of operations that allow you to do things at either end of the collection. We have add first, add last, get last, and remove first and remove last. And so these are promoted from the deck interface. And so the deck interface actually already had these. And fundamentally, there's no reason that these couldn't be on any list. I mean, a list allows you to do completely random access on the elements. And so they just aren't there. And so if prior to JDK 21, if you wanted the convenience of say, getting the last element from a list, you actually had to use an indexed operation to do that. And I'll show that a little later. It's not a big deal, but it just sort of, why isn't there a get last method on it? So, that set of operations at the end are on sequence collection, and so now that's inherited by list and also by the ordered collections, or the sequenced sets, such as LinkedHashSet and sorted set and navigable set. And then there's a kind of a new method as well, which is called reversed. And what this does is it returns a reverse-ordered view of the underlying elements of the underlying collection. And so it's a view, and I'll explain that when I get to the demo. So navigable set already had a method called descending set, which actually has exactly the same semantics, but the name is a little bit wrong. So descending set makes perfect sense if you have a navigable set. You want the descending view of the navigable set. Okay, that's great. I think it's a great concept, but it's the wrong name for putting here. So I renamed that to reverse and promoted it up to sequenced collection. So now all of these collections have a reversed method as well, list and LinkedHashSet and so forth. Okay, the SequencedSet interface is a subtype of sequence collection. It doesn't add anything really, but what it does do is it provides a covariant override of the reversed method. And so instead of returning sequenced collection, if you call reversed on a sequenced set, you get back a sequenced set, which again is a view of the underlying collection with the elements in the reverse order. Okay, sequenced map is a little more complicated. This was a bit of a wrestling match because the naming conventions on the map side of the house are not very good. So in a map, you don't add elements or you don't add entries, you put them. So we have put first and put last. There's no get on a map except to look up an entry, but this notion of retrieving the first or last entry is expressed by these methods that were on navigable map called first entry and last entry. Unfortunately, not get first entry, get last entry, but that's what we had, so I didn't want to add new methods just to have a trivial rename. So we'll just have those as first entry and last entry. Removing is a little weird. The way that navigable map spelled remove is poll, and what that means is give me an entry, but if there isn't one, just return null. And so poll first entry and poll last entry are actually the way you remove entries from a sequenced map. There's that reverse method again, and then unique to maps is this idea of these different map views. There's key set, values, and entry set, and those have been on maps since, I think since 1.2, so those have been around forever. So what those do is those give you a filtered view of what's in the map. Now, if you have a sequenced map, maybe you want those views to be sequenced. And so what's been added here is a sequenced key set, sequenced values, and sequenced entry set. And those have the corresponding return types of the sequenced set and sequenced collection. So anyway, we have the methods that retrieve the map views that have been added to SequencedMap Interface. Okay, so let's show some code snippets here. Suppose we have an operation that you want to do, such as to remove the first element from a collection or remove the last element from a collection. Okay, so if you have a list called a list, you remove the first element by saying remove 0. Oh, pretty simple. Okay, how do you remove the last element? Okay, a list.remove. Okay, all right, well, so you have to find the index of the last element. So that's size. Oh, no, actually it's not size, it's size minus 1, because size is the number of elements, and since we're zero-based, etc., I'm sure everybody's made that mistake, you have to use size minus 1. Okay, not too difficult. Dec, as I said before, those had this nice family of first and last operations already. So dec has remove first and remove last already, so that's kind of nice. LinkedHashSet, okay, so now this is really bad. LinkedHashSet has always been deficient because basically it does not add any, well, prior to JDK 21, it did not add any new methods to the set interface. And the set interface has no notion of getting elements. And so, well, you can kind of get an element by getting an iterator, and that gives you access to the elements, and you can remove elements by calling the remove method on the iterator. So removing the first element, you get the iterator, advance to the first element, and then call remove on the iterator. That's kind of a roundabout way, but it actually does work. How do you remove the last element from a linked hash set? Okay, well, basically, you have to index all the way to the end, and then remember the last element, and then call remove on the iterator just before you step off the end of the noise. Anyway, so I didn't even bother to put that code here. It's so hard that I think nobody wants to do it. Or what you could do is basically maintain the elements in another data structure, so you know which one is the last element. Navigable set is not too bad, but again, remove is spelled pull, so you can pull first and pull last elements to get the first and last elements out of a navigable set. Okay, so now in JDK 21, since all of these inherit from sequence collection, everything is nice. To remove the first element, you just call remove first on any of these. To remove the last element, you call remove last on any of these, and it just works. Okay, now let's, oh, nice, a little bit of applause here, thank you. Okay, so now, iterating in reverse. All right, so iterating in reverse is one of those things. It's like, you don't use it that often. But when you need to iterate in reverse, boy, is it a pain. And sometimes you do. You don't need to iterate in reverse very often, but when you do, you need to. So how do you iterate a list in a reverse? And there are a bunch of things like this. There's a whole bunch of Stack Overflow answers about this, and they all have these various techniques. You can use indexes and stuff. What I'm showing here is a list iterator. And so most people don't use iterators anymore because you just use for each, and that just, that's the way you iterate something forwards. How do you iterate something backwards? Well, okay, so the first thing you have to do is drop back from the for each loop back to the old-fashioned for loop, and then use the list iterator interface. You start off by positioning at the end, and then you say has previous, and that lets you step backwards through the list. Okay, so that's kind of a mouthful, and it's also list iterator is a bit of an obscure interface, but it does work, and you can do it this way. Dec is a little interesting. There's another thing on Dec called descending iterator. It's just like the iterator method. It's just that it gives you the elements in the reverse order. So that's kind of nice. But you can't use the for each statement with descending iterator, because for each uses an iterable which says it gets the iterable by the iterator method. So there's no way to tell the for each statement to use, oh, use this different iterator. So you have to, again, you have to use the old-fashioned for loop and get a descending iterator. And then what's weird is it's a descending iterator, so has next and next actually move backwards. And so that kind of does the same thing as the list. It's just that it's spelled differently. Iterate a linked hash set in reverse order, just give up. Copy the elements somewhere and reverse them. Really, there's no tractable way to do it using a linked hash set directly. Navigable set, okay, now this is the interesting one. Remember I was talking about this idea of the descending set view. So here, this is nice. Navigable set, you ask for its descending set view, and you get back a navigable set, and then you can just, yeah, that's right, and then you just use the for each statement over it, and you get the elements in reverse order. So the point here is that I took the idea of the descending set method and then promoted it and renamed it. And so now it's called reversed. And so now, all of these inherit reversed from sequence collection and list, dec, linked hash set, and navigable set. You just say, I'm going to iterate the reversed view, and you get all the elements in backwards order. Okay, now, a little bit more of a challenge. Suppose you want to have a stream in reverse order. Okay, so I'm going to start off with navigable set, because that's the easiest one. And so again, you get the descending set, but instead of doing a for each over it, you just call stream, and you get the elements in reverse order. Okay, so that's really nice. So that's what we're going to build on here. List, if you want to build a stream, I'll actually show some code that does this later. It's kind of involved. But basically, you can build an adapter that takes a list iterator and returns an iterator in reverse order, and then you turn that into a splitterator, and then you turn that into a stream. It's kind of involved. And then there's also a variation that uses a stream factory method called stream.iterate, but you kind of have to stand on your head to use it. So I'll show that a little bit later. Dec kind of has the same issue, but you already have an iterator that goes in the order that you want, so you just use the descending iterator method on that. And once again, poor old linked hash set, no chance. All right, and then so streaming in reverse gets the same treatment, right? Now we have the reversed method, and that gets you a reverse ordered view, and then you just call stream on it. And so it's all the same. Just call reversed.stream, and you get exactly what you want. Okay, so a couple things. The sequence collection interfaces are useful in APIs. If you've ever written an API where you want to say, I want to pass around a collection, but I want to make sure that this collection is, has a defined encounter order. And so you could use list, but the problem is if you don't actually have a list, if you have something that's ordered but isn't a list, then you're going to force somebody to convert that to a list. So instead, now you can say, oh, well, if you want something that's ordered, just have sequenced collection in the API. So either use that as a parameter type or a return type. The other thing about list is that list requires indexing, and sometimes you don't know the index of something. It's not handy, and so list is actually kind of too powerful. And so sequence collection is sometimes nicer because you say, I know how to generate this in a particular order, and so that's a sequenced collection. But I don't want to bother having to number them. If somebody says get 5, it's like, well, how am I going to get the 5th element? Maybe I have to do some extra work to figure out what index something is at. So that's nice. Another thing is if you wanted to return, a common problem is that if you wanted to return a collection that has things in a particular order that's not a list, you could return a linked hash set. But again, that's an implementation. And so I think people have objected to that quite rightly because it's like, I do not want to put implementation types into my APIs. So again, that's this whole problem of a missing interface. And so instead, you can return a sequenced set, which fits up nicely. It's an interface that fits nicely above linked hash set. Let's see, yeah, so talk about a little bit more about LinkedHashSet and LinkedHashMap here. I think I covered most of this already, but early in the JDK, I think people perceived the need for a collection that had ordered and unique elements fairly early. And so in 1.4, LinkedHashSet and LinkedHashMap were added as a response to this. And they're kind of sort of okay, and as I've mentioned before, these are implementations only. They're not interfaces, so that's still missing. But they also have a bunch of weird things about them. LinkedHashMap in particular is by default an insertion order, but it has this other mode called access order. So if you call get on a LinkedHashMap, it will actually reorder the elements as a side effect. And also you can use, you can subclass and override remove eldest entry. And you can use that as a very rudimentary cache invalidation protocol. And so it was very strange having LinkedHashMap be that way, because it was such a special case. I mean, if it did exactly what you want, then great, you could use it. If you wanted to do something slightly different, you couldn't use it at all. So it was very strange. It was kind of uncharacteristic for the JDK. So what resulted, though, is even after LinkedHashSet and LinkedHashMap were added, people kept asking for, it's like, I want a list with unique elements or a set that maintains order. Anyway, so we've retrofitted those with SequencedSet and SequencedMap, and I think that provides all the operations that I showed on the previous slides on these elements. And I will demonstrate how they actually make LinkedHashSet and LinkedHashMap much more flexible, because you can reorder elements not quite at will. I mean, it's much more flexible about what reordering you can do on those classes. OK, so let's switch over to demos here. I'm going to do 4 demos, and I'll just dive into the code here. OK, so the first one is I want to talk about the reverse ordered view. All right, so I hope everybody can read that. All right, so I created a list with some strings, alpha, bravo, Charlie, delta, and then I created a reverse ordered view of it. So it's a view collection, and so it's not creating a copy. What it's doing is a view collection is something that stores its elements in some underlying collection. So we're not making a copy of all the elements. We're just having it's like putting glasses on. You have a different, it's like looking at something in the mirror, actually, is a good example for reversed. So I have a reverse ordered view, and here, let me run this. The first thing is the reverse ordered view is pretty obvious: Foxtrot, Echo, Delta, Charlie, Bravo, Alpha. Okay. Also, the reverse ordered view, if you call reversed on the reversed view, you get back the original thing. That's not guaranteed, but I think most of the collections do that. Now, the thing about it being a view is that they have side effects on each other. So if you have a reversed view of something underlying, if you modify the underlying collection, then you can see that in the reversed view. So I called list.set to xyzzy, and you can see the change here, but that also shows up in the right place in the reverse view. And not all collections support this, but ArrayList does. If you modify the reverse ordered view, so here I'm saying rlist.set, I'm putting plu at a particular location in the list. Notice I'm using the index of the reverse ordered view, so it ends up here at the right index in the reverse ordered view, but that gets written through to the underlying collection, and so it shows up in the right place in the original collection. So that's what I mean by a view. So the view does not have the elements on its own. It just sort of reverse orders the things that are in the collection underneath it. All right, I wanted to talk a little bit about getLast. And so getLast really, I mean, it's so low tech, but it's also really convenient. So suppose you have some kind of application where you want to fetch a list of items from somewhere, and then you want to process the last item in that list. Okay, so the first thing you have to do is fetch the items, then get the last item, and you see this items.size -1, like I showed before, and then you process the item. And so you could probably compress this down if you wanted to inline items.get, but that kind of makes this a bit involved here. But you really need to have a local variable here because you use it twice. You get the size, and then you get something based on the index that you got from the size. And Sometimes what people do is they call fetch items twice, and but if fetch items has side effects, you don't necessarily want to do that, or if it's expensive, you don't want to do it twice just to make it more convenient. But getLast is pretty nice because you can replace this expression here with getLast. Okay. So now you can inline this. You can inline this local variable because it's only used once. And then, in fact, you can actually inline this expression here. And I should do this in the IDE, but it didn't work. I'm not quite sure why. But anyway, so you just say, oh, I want to process the last item. Fetch item's got the last one, process it. And so it's a small thing, but you've just compressed 3 lines of code down to 1. It's like, that's pretty nice. Okay, I want to talk about LinkedHashSet and the new things here. So let me run this to show you what happened here. All right, so I created a LinkedHashSet with A, B, and C in it, and I added D as the last element. I'll just show you the output here, but actually you can see the code on the screen. Okay, so add D as the last element. Okay, you get A, B, C, D. Now, what if I add B as the last element? Well, B already exists in the collection. Well, so if you add the same element, since LinkedHashSet has unique elements, you're not going to get 2. So what it does is it takes the existing element and moves it to the end. And that's something that wasn't possible at all in the LinkedHashSet before. So the same number of elements is in the set, but just their order changes. And so if we add, whoops, similar with add first. So if we call add first on E, then that goes at the front. But if we add first on C, which is already in the collection, then C just gets moved to be the first element. So you can reorder things in a LinkedHashSet pretty easily this way. Okay, and then finally, I'm not going to spend too much time on this, but this is what I was talking about before. If you want to get a stream of these elements in reverse order, prior to JDK21, you had to create this iterator here that basically says, oh, my hasNext calls the list iterators previous, and my next calls the list iterators previous. And so that gives you the reverse ordered iterator. And then you turn it into a splitterator, and then you turn that splitterator into a stream. And it's like, by the time you got through all this, it's like, what was I trying to do again? So I demoed this at a previous conference, and Remy Forak said, oh, no, it's much easier to use stream.iterate. Well, maybe. Okay, so it's like, okay, it doesn't actually do quite what you want to do, but what you need is a Boolean to tell whether you actually have an element. Okay, so we already have something that fuses an element with a Boolean, and that's called optional. So you have to do this stuff where you iterate over an optional of the elements of the stream using previous blah, 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 blah. It took a while to figure this out, and it's not clear to me that this is what anybody would actually want to do. So nowadays, with JDK21, if you want to stream something in reverse, you just call reverse.stream, and you can see it all right there, and it works great. Okay, thank you. Okay, back to the slides here. All right, I'm going to have to run through these really quick. I think one of the main things is that I wanted to reuse methods as much as possible instead of creating new ones. So the naming, there's a clash here. Some things have good names, some things have less good names, but in order to avoid interface proliferation, I just kept some of the same names. So that's why you see poll showing up in the map interfaces. I think this is an interesting one. It's like, suppose you want to do getLast on an empty collection. What should it do? Should it return null, or should it throw an exception? And it turns out that the linear collections like list and set, they're more sort of exception friendly, and so those throw no such element exception. The map stuff is just because of the way navigable map was designed, it prefers null, and so I kept that. Even though that's inconsistent, I think it would be worse to create inconsistency, some having more map things throw exceptions and some of them throw nulls. There is a problem, which is that if the collection allows null, then if you say get first and it returns null, does that mean the first element was null, or does that mean there are no elements? And so I think that's why it's less ambiguous to throw an exception, even though that's sometimes inconvenient. The fact is, you either have to check first to see if the collection is non-empty before getting something out of it, or if you get a null, then you have to check the null afterwards to see. So you have to check one way or another, and so this is the way we ended up. I think I covered that already. So you might remember on the class diagrams there was Q way up in kind of the corner, and that's not in the sequence collection family. And the reason is that Q is a little bit of a weird bird. It's not really something that that a class typically uses to maintain its own state. Rather, it's more for communication between different threads. But there are also some weird things like a priority queue actually does not maintain its elements in a particular order. Priority queue is, it stores a heap in an array, and the ordering of a priority queue is only expressed when you remove elements from it. And so you can only discern the order destructively. So it's really weird. So it just didn't fit in the sequence collection idea. And it's also almost impossible to get a reversed view of it. So Q is not part of the sequence collections hierarchy because it has its own specialized uses. So I had to leave it out of the sequence collection family. Covariant overrides. I think this is a pretty big deal. Reversed is a new method, and so it's safe to add covariant overrides in a bunch of places. So what I've tried to do is, at every place that introduced a reverse method is to return a specific type. So if we have SequenceCollection.reversed returns a sequence collection, but if you have a list and you call reversed on it, then you get back a list. And so that means you can use all the same things, all the same operations on it. So if you have a list and you reverse it, you can get all the indexed operations or index of or things like that. And then same with dec and navigable set. Yeah, and there's a similar thing going on here. There's some compatibility issues that I spent a lot of time on. In a sense, if you have a sequenced map, you might expect that the key set would also be a sequenced set. But actually, that causes a compatibility problem because it could potentially break subclasses. So what I did instead was added 3 parallel methods: sequenced key set, values, and entry set. And those are how you get the sequenced versions of the map views. Yeah, there's this weird thing in here. So the thing about covariant overrides is that they're very powerful. So if you have a sequence collection, reversed on a sequence collection returns a sequence collection. SequencedSet.reversed returns a sequence set, and so forth. List.reversed returns a list, and dec.reversed returns a dec. Great. What happens if you have a class that implements both of them? Well, it turns out this is pretty rare, but there's a class in the JDK that actually implements both list and dec, and that is the aforementioned linked list. And so I had to do kind of a weird hack where basically the reversed method of linked list actually returns a linked list. Even though it's a reverse ordered view, it's not really a linked list itself, but its type is a linked list. So that works. This is probably one of the riskier changes. I did a search of a lot of source code in the open, and I think there are very few cases where there was a single collection that implemented 2 different collection types from different parts of the hierarchy. But there probably is other cases. There probably are other cases of this out there somewhere, and this will. I think this is binary compatible, but if you try to recompile such a class against JDK21, you will get a compilation error because you will have a conflict between when you try to go implement. When this tries to implement the reversed default method, it says, hey, there are 2 interfaces in the hierarchy. There's a conflict here. You have to resolve it by doing that in your subclass. And that could be kind of painful. But I haven't heard anything about anybody have any problems with that. So I'm crossing my fingers that this is a fairly rare case. Yeah, there's one little oddity here that you might have picked up on if you were paying extremely close attention and you were an expert at all the collections APIs. I said previously that there are this family of add, get, and remove at both ends of a collection, and that's great. So if you want to add something at the front, you call add first. Okay. Well, if you have a navigable set, the navigable set says, well, whatever you give me, I'm going to put it in the right place depending on where it goes in the sort order. So it doesn't make sense to have add first on navigable set. So on the other hand, everything else about sequenced set makes sense with a navigable set. So what do you do with add first? Well, we could introduce a bunch of new methods to have, a bunch of new interfaces that omit this particular method, but that would, I think that would be confusing, just adding interfaces for this special case. And instead, so what I said is, I'll just pull the usual collection trick of, all right, just don't use add first on navigable set because it'll throw an exception, throws unsupported operation exception. And so yes, this is definitely an asymmetry, but I think it makes the otherwise makes the class, enables us to have an interface hierarchy that is very clean, and these interfaces fit in quite well with this small exception. This isn't a design issue. This is just a clever implementation hack that I came up with. If you look at all of the things I've talked about, pretty much didn't require any implementation. Didn't require much implementation to implement a reverse-ordered view. It's pretty easy to have a reverse-ordered view of a list or a deck or even a linked hash set. In fact, internally, the linked hash set was a doubly linked list. And so internally, it had all the information it needed already to iterate in a reverse order or to provide a reverse-ordered view. It just was not exposed in the API. Navigable set and navigable map also have equivalent power. In fact, they have the descending set and descending map views already. So those provided already. Sorted set does not. If you look at sorted set, it's kind of been superseded by navigable set. But it has a fairly restricted set of methods that would allow it to it doesn't look like you could support reverse ordered view, but I actually did something clever here. There's a weird thing you can do with the head set method of sorted set, where you can actually use that to build a reverse ordered iterator, and then giving a reverse ordered iterator, you can create a view. So if you iterate, and the usefulness of this is that there are implementations in the wild out there of collections that implement either sorted set or sorted map, but not navigable set and navigable map. And so I think this is useful because those existing collections out there now get the goodness of SequencedSet and SequencedMap. So just to bring more collection implementations, third-party collection implementations into the fold. Okay. All right. So here I am almost at the end here. So this is a bit speculative. So it's like it's been a couple years after JDK 21 has been released. And so where are we going from here? So before I talk about where we go, I want to talk about a tiny bit of history to set it up, which is in JDK 9, I added the list, set, and map factory methods. You can say set.of, map.of, and so forth. And those create unmodifiable collections. In particular, set.of and map.of do not have a defined encounter order. So here's this ordering thing again. And there was a bunch of discussion at the time that said, oh, actually, some programs prefer having something that has a defined encounter order. So there was some back and forth about should set.of and map.of actually define an encounter order. And in fact, the decision was no, they do not define an encounter order. In fact, it's randomized. But the thing there is that you can see the missing type again. If you say set.of and it has a defined encounter order, the type is indistinguishable from, say, a hash set, which does not have a defined encounter order. So again, there's a missing type that said this set or this collection has an order. Okay, now we have sequence collection that says this collection has a defined encounter order. So we can go back and add new methods like SequencedSet.of or SequencedMap.of that are kind of like set.of. It's just that they keep those elements in a predictable encounter order instead of randomizing the order. So these are not added yet. I think this is an idea, but this is something that's now come back up, given that we have the unmodifiable factories and we have now the sequenced types. Now, this is a fairly obvious extension, so I think this is something that we might be working on in the next few JDK releases. Finally, there's no need for SequenceedCollection.of because you just say list.of and you get a sequenced collection. So anyway, so I think this is something that we'll probably be working on in the near term. Okay, so where do we end up? Sequence collection provides 3 new interfaces that convey the semantics of collections that have a defined encounter order. What comes along for this is a nice set of methods that allow operation at each end and that provide reverse ordered view. And also, kind of as a side effect of this, we've done some work that lets LinkedHashMap and LinkedHashSet give a lot more flexibility, and so you can operate at the ends of a LinkedHashSet and LinkedHashMap that you couldn't before. All right, so here's some links for further discussion. JEP 431 is probably the best detailed design overview of this. If you go on the Java Playground, you can try this stuff out. It's all in there. And if you want to reach me on the internet, I'm on Mastodon at this address. Thank you very much.